All right, good afternoon. Welcome back. Let's 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 continue. We have our last session of the day. We have Linus, Chérifa, Sarah, and Abdel, right? And the first presenter is Linus. Linus, you can come in.
Okay, good afternoon, everyone. I hope you're all doing well. This is our last session. I hope it turns out to be one that actually warms you up, ends the day well for you. I'm going to be presenting on innovation and water productivity, empirical evidence from water-related patterns. This is work that I've been doing with two other colleagues of mine, Zining, who she's still at Gettysburg College with me. Niras is now at California State University. And what we do here is we examine or we focus on cross-country comparisons of the effect of water-related innovations on water productivity. And we focus mostly in terms of the two variables here, and others we focus on macroeconomic indicators because those make it easier to compare across countries. And we approach this work in two steps. In the first step, we use the common Cobb-Douglas production function to incorporate water as an input. And that's sort of how we introduce technology in the relationship. And then in the second step, what we do is we specify an empirical model that makes use of the same factors we have in the production function, add some controls, and then use robust statistical models to estimate the relationship. We do comparisons amongst developed countries and developing countries. And for the entire model, what we find is that there is consistently a negative and statistically significant relationship between water-related innovations and water productivity. I mean, that has its own implications, but we don't quite call that a groundbreaking result because there is one other sector in which you observe this, and that's the only case where you observe this negative relationship. And so, in terms of the motivation, a lot of the discussions we've had here over the last few days provide really a straightforward motivation for what we do here. And you can think about this in terms of the water food energy nexus, or you can think about the ways in which water interacts with other sustainable development goals. There is a huge report out there that focuses on this, analyzes the relationship between water and about 12 other sustainable development goals. We've talked about the degree to which climate change is going to affect African countries in particular, and we've sort of emphasized the effect on the agricultural sector that employs a large number of people, especially women. And so the effects are going to be disproportionately affecting people in Africa as well as by gender. And what we do here is we say, okay, we already have some information on innovations, and we've had a discussion here on what is an innovation, how to measure it. Here again, like I said, we focus on aggregate indicators that make it easier for us to compare across countries. And we use a definition of technologies that is published in Biannual et al. 2016, which defines water-related technologies as those that contribute to the continuous improvement of water management in terms of efficiency and effectiveness. For water productivity, again, we use a relatively common indicator, which is GDP per cubic meter of total fresh water withdrawal. So goal here really is to go back and ask the question, okay, we've been talking about the adoption of technologies, technological development. We take a step back here and ask, well, we already observe some of this. What are the potential impacts? And in terms of trends in water innovation, this data is from the OECD. What surprised us a little bit is that when we started looking at the data, you see that a lot of the innovations in the water sector are focused on pollution abatement. They also break down the data into demand-side innovation. When Mike was presenting yesterday, that was one of the things he talked about as what they use to be able to manage or get through the crisis in South Africa between 2015 and 2018. And then, so supply-side innovation are those that focus on water conservation, irrigation, power generation. On the supply side, the goal there is to increase water availability. Relative to other types of innovation, water innovation remains relatively low. Again, this is more data from the OECD database. And you can see that the water-related innovations remain relatively low, although with a good, slight trend upwards over time. Climate change mitigation technologies have taken up significantly. Environmental management technologies have taken up significantly relative to water innovation. So again, we take a look. We ask a simple question: do these innovations in the water sector improve water productivity? And whether or not this outcome differs across developed and developing countries. We draw from two strands of the literature. One of them focuses on project-level interventions. This is where you observe a high concentration of irrigation projects. In fact, this review here studied or went through well over 230 studies, all focused on irrigation. And the sort of general consensus you would say with this is, what you observe is, with these interventions or innovations, you tend to observe an increase in water withdrawals by farmers, and you also tend to observe an increase in farmers' income. Another type of intervention, policy interventions area, this is where you do a lot of work. The sort of general consensus here seems to be that policy interventions aimed at reducing water withdrawals tend to work pretty much. This is really where we seem to have a direct relationship. And as you can see here, there is a relatively large number of sectors in which this relationship has been studied. Studies have focused on firm level, those that focus on the health sector. But what I do want to point out here is there seems to be, for all of this, there seems to be some consensus that innovation has a positive effect on productivity, with the exception of ICTs. And I will say a little bit more of this when I talk about our results. So our contribution, we are hoping that will make a splash by contributing to this work in the water sector. I hope you don't mind me throwing these questions up here. Part of the reason I threw them here is because what we do here highly relates to some of the things we've talked about so far. And I thought I should share that with you. So we consider a simple Cobb-Douglas production function where output here, Y, is a function of total factor of productivity, or we call this technical efficiency, capital, which is an input, labor, input. This is what we introduce in that model. B here, we consider it to be the equivalent of the total stock of knowledge in the water sector. W here represents water use, or water withdrawals. These parameters here, alpha, beta, gamma, these are the equivalent of elasticities, the equivalent of what you would consider to be the responsiveness of these inputs here. The responsiveness of output here with respect to these inputs. We take this B here, stock of knowledge in the water sector, and we define the behavior as a function of R&D expenditure. This is what enables us to introduce innovation in our model. And we we look at the data we have, and it appeared to us that it would be better to sort of define these variables in terms of their growth rates. So we take this function here, we simply divide by the water use, and then take the log linear form of it. You differentiate this with respect to time. Essentially what you get are growth rates. What this says is the growth rate of water productivity is a function of the growth rate of total factor of productivity, capital, labor. This is the variable of interest to us here. The theoretical interpretation here is that there should be a positive relationship between innovation and water productivity. This here is water use, and you see the prediction there is that the relationship should be negative. What this is saying is if you observe high levels of water withdrawals, there is a high probability that water productivity is very low. And if you go back to what we said over the last few days, agriculture accounts for the largest withdrawal of water, but it is also the least water productive. So this is what this here is saying. Now we use this to specify a linear relationship for empirical model. As you can see, it has all the variables that we had before, but what we do add is a vector for controls, and those controls are things like GDP per capita. We've talked about the importance of human capital, talked about the importance of governance. We've talked about the issue of water stress. Here we take total fresh water resources as the equivalent of water endowment. That's what we use for controls. The other thing that was said, I think it was the first day, Ariel was the one that pointed this out. The part of the reason that Africa will suffer the effects of climate change is because of its location. So given the structure of the data that we have, we include time invariant factors, or we use a model that accounts for time invariant factors. And of course, it's up there. And then we also use models that account for accommodates time variant factors. Forgive me if you cannot quite see the numbers here, but this is just the summary statistics. We use data from the OECD database, the World Bank database, Penwell tables, and the Global Adaptation Initiative from the Notre Dame University. When we looked at the simple statistics here, or summary statistics, what we didn't see was the problem of the potential problem of outliers, and that's really what we were looking for. So what we do is we fit the benchmark model for the entire sample, and again, for the data that we have here, we have data for a total of about 81 countries. I think 46 of them are developing countries and 35 are developed countries. And the data is for the period between 2000 and 2019. So given the structure of the data that we have, we try to figure out which of the empirical model would better capture the characteristics of the data. And so we chose 3. One of them we believe to be among the weakest. 2 of them, these 2 here, we believe might better fit our data, but they fit the data in slightly different ways. What I want to focus on is really just this variable. As you can see, most of the other variables, as well as their controls, they have the correct sign. And some of them are statistically significant, but I'm really focusing on water innovation variable. See that it is negative for fixed effects, this model, we call it model 1. For model 2, it is also negative, but statistically significant. Wherever you see 1 star, it's weak evidence at 10%, 2 stars, strong evidence at 5%, 3 stars, strong evidence at 1%. So this is, like I said, the model that we predicted or thought it would be the weakest. So we focus on this two going forward. So this is saying that it's a relatively strong negative relationship between water productivity and water innovation in this case. Now, these models here make a series of assumptions, and we did want to make sure that our results, that those assumptions are validated in our estimation, and this is just an illustration of that. So we go back and ask whether the result would be different for developing versus developed countries, and then we rerun the model. So this column here is the results for developing countries, and this one is for developed countries for model 2. This one is the same thing for model 3. And again, what you can see here is that the coefficient for developing countries remain negative, but statistically insignificant. And here you see that it is negative and statistically significant. You see the same thing for the model 3 here for us. And there is a name for this result that is derived from the ICT studies. They refer to this as the productivity paradox, and it has its roots in a quote from the New York Times in 1987 by Robert Solow. You can see the computer age everywhere except in the productivity statistics. So since then, there has been a rise in the studies of in the ICT sector yielding exactly the same result. I'm sort of seeing similar studies focusing on artificial intelligence, and it appears that this outcome is consistent. So we've been talking again here about the importance of high performance in terms of institutions. So if we consider high performance, in other words, we come back here and we simply ask, is there some possibility for a threshold effect? In other words, is there some level at which this result would switch from being negative to positive? So there is quite a bit of results here, but this is what we should be focusing on. What we do here is that we take developed countries separately, and for each group, we separate countries that fall below its mean for this variable, and we run regressions, and they are reported in this column. What you see here is that for developing countries, the coefficient switches from being negative to being positive. Though it's still statistically insignificant, the same thing happens for developed economies, but the coefficient switches from being negative to being positive. In other words, what we take away from this is that there is some threshold effect. And then we go through some robustness checks. What we do on this table here is that we use different proxies for our variables, essentially, and we get exactly the same results. We use other methods for robustness checks. In other words, in this case, we drop one variable at a time. The results are consistent. What you see in the bottom part of the tables here is we didn't want to use so much space in the paper by reporting this in separate tables. And so these are just the robustness or the validation of the assumptions of the respective models. So instead of dropping one variable at a time as we do here, we drop a set of variables in our model. So we start with just these two. As you can see, the results are relatively consistent. One of the explanations for the productivity paradox you will see in the literature is that, well, technology takes a while before the effects can show up. And so what we do is we try the lag. We lag our dependent variable here, which is water productivity. You can see it's statistically insignificant. We also lag our main variable here, which is water innovation. As you can see, they are statistically insignificant. Those lags are statistically insignificant. So in other words, it's not necessarily that the effects of technology in this particular case are lagging there might be some other explanation for this. So just to conclude, we do find a productivity paradox in the water sector, and this applies to developing and developed economies. When I presented this to my colleagues 2 weeks ago, they said, well, Linus, you cannot include, you cannot be saying you find a paradox in developing countries because the coefficient was not statistically significant, but it's the case that in the literature, the definition of the paradox is basically that you do not observe the effect of innovation. So even if you do not find statistical significance, that is also saying, well, you expected one, it's not there, and therefore a paradox exists. All right, so, I mean, I don't need to repeat the last result here. Christina wants me to stop. Thank you.
Thank you.
Because
Thank you
you are
very
so
much.
nice.
Thank you very much, Linus.
Yeah.
We're inviting Chérifa to provide her discussion. Thank you.
Yeah. You want to? Okay.
Thank you for your clear presentation. Yes, coming from engineering background, yes, I read your paper, but I asked also a colleague from economic background. Yet he is Professor Samir Maliki from University of Brest, France. And he helped me in order to give you some comments. Yes, for my side, I have just two. The first one, this article aims to estimate a water productivity growth function by analyzing panel data from developing and developed countries. The primary objective is to investigate the impact of technological innovation on water productivity. Okay, the second, yes, it's okay. It is just a general appreciation. The article is well structured and clear. It starts by outlining the research objectives, the methods, and key finding, which is good practice to provide a concise overview. The paper's objectives is to examine how technological innovation affects water productivity. This research question is important and relevant as it addresses a critical issue related to water resources management. Yes. This is my two comments.
Okay.
Yes. The comments of my colleague, he's also provided the course of water economy at Pan-African University. He said that the authors use a panel instrumental variable, IV, and system generalized method of moment, the GMM estimations, which are appropriate techniques for analyzing panel data. However, it doesn't provide a concise details about the choice of instrumental variable or the rationale behind the GMM approach. This is the first point. The second one, the research reports as a surprising result, a negative and statistically significant relationship between innovation and productivity in the water sector in both developing and developed countries. This finding contradict economy theory expectation and highlight a productivity paradox in the water sector. There is also some other comments. The introduction of an alternative proxy variable for water productivity calculated as GDP divided by total water usage is a methodologic choice worth noting. It's aligned with the theoretical definition of water productivity mentioned earlier. However, it would be beneficial to provide a rationale for this choice and discuss its advantages and potential limitation. Another comment also, the alternative proxy variable still shows a negative and statistically significant coefficient on the innovation variable, reaffirming the earlier finding. This reinforces the robustness of the results. It's a positive aspect that the study tests the finding with alternative measures. And the last point is the negative and also statistically significant impact of water-related innovations on water productivity remains consistent at the 5% significance level. This is important information as it highlights the statistical significance of the finding. However, it would be useful to specify the magnitude of the coefficient to understand the practical significance as well. Thank you.
Okay. And thank you very much. Just to respond. So the second one, I'm not quite sure it's just a comment or it's a question, but I will start from the third one, which is you read through the paper, we really don't interpret the results in terms of the coefficients, which is what I think the reviewer is getting at. That's all. That's easy. Let me just also say, the paper as a draft has a lot of cleanup there. I could go through the paper itself and point out areas where I think, for example, notation, we have to go back. And again, if you've worked together on a paper, you know how hard it could be. 3 people working on a paper at the same time, have a discussion, we go back, and then all of a sudden we come up with different understandings of what notation to use and where and things like that. So because we use the variables in logs, those logs are essentially the equivalent of elasticities. So interpreting elasticities is very much straightforward. We can definitely address that. That is, interpret the results in terms of the coefficient itself. So the rationale for choosing two-step system GMM is guided by the type of data structure that we have. Same thing with the panel IV. They are, so what is, I don't want to get too technical here, but for the system GMM, it uses what we call the moment condition to be able to compute the unknown population parameters, which is what we specify in our model. The advantage with system GMM is that it automatically selects the instruments for you. And those instruments are basically the lags of the dependent and independent variable. You can choose them and specify, or you could specify the model on Stata, which is what we use, and allow it to select that optimum lag for you, which is what we do here for the most part. I think we could explain more of that in the paper, that's for certain.
Thank you. Thanks, Linus. Are there any other questions out there? All right, no, that's fine. If we don't, people are a bit tired, probably. It's over to you, Chérifa, as the next presenter. Thank you.
Yes, ladies and gentlemen, good afternoon. Yes, coming from engineering background, I will just share with you some like ideas related to a project. We started it just 9 months ago, and it is related to wastewater use for agriculture as an adaptation measure to water scarcity and climate change. And I choose 2 case studies from Algeria in the west part. Yes, in Algeria, the use of treated wastewater in agriculture has become an important focus of the new water policy in the country. The ambition of the country is to treat 1 billion cubic meters of wastewater in order to irrigate more than 100,000 hectares. Yes, the number of the wastewater treatment plants operated by the National Office of Sanitation is more than 150 plants last year. In August 2022, 14.6 million cubic meters of treated wastewater by 17 wastewater treatment plants has been used for irrigation. Yes, this is like I will share with you the first part of our project related to the irrigation using reused wastewater in Algeria, environmental impact and socio-economic aspect. And I will just share with you the first part related to the assessment on the quality of the treated wastewater for agriculture purposes. This project is funded by the Thematic Agency for Science and Technology. Yes, we have two for this study. We have two kind of methods called the water quality indices. We selected these two methods. The first one is called the Canadian method, and the second one is the arithmetic method. And we will apply these two methods for the wastewater treatment plant of Int'l and the wastewater treatment for of Tlemcen. We have using 10 parameters in order to evaluate the quality of the reused wastewater for irrigation purposes. For the wastewater treatment plant for Int'l, we have a data from 2014 to 2017, and for Tlemcen from 2020 to 2022. The methodology is the first step is the data collection and the data analysis following the Algerian standard, the statistical analysis, and then the water quality index determination. Yes, for the step of data collection, we have to remove the missing data and the outlier, and then to test the normality, and then to calculate the water quality index or indices. Yes, the first method called the Canadian method, the Canadian Council of Ministers of Environment. There is like 5 rank. We have to calculate. And the second one is the weighted arithmetic water quality index also. We have also 5 classes or range, and we have to calculate in order to see if this water is we can use it for example for drinking, for irrigation, or for industrial purposes. I didn't know. Maybe I removed the slide related to the equations. Yes. The first case study is for Int'l. It is situated in the west part of Algeria. It is agriculture region. The agriculture area is more than 76% of the total of the surface of the region, with population more than 400,000 inhabitants. The wastewater treatment plant of Int'l is like is working with the process of activated sludge. The operation of the plant has started 9 years ago. Yes, this is the 10 parameters used in order to have an idea about the quality of the treated wastewater. For example, the first parameter is the temperature. The second one is the pH. We can see that at the output of the wastewater treatment plant, all the parameters are in or are respecting the norm or the standards. This is some parameters related to the process, the BOD, the COD, the nitrate and nitrogen, the ammonium, or the parameters, the heavy metals, for example, also. We can check that all the results are in the norm. The result of heavy metals parameter show that all the values are below the values recommended by the Algerian government related to the water reuse recommendation. Yes, related to the microbiological analysis. Yes, we have some over we have some over values. These values are related especially to the microbiological, for the coliform and for the intestinal nematodes. But for this wastewater treatment plant, we have like a tertiary treatment. There is no problem with the quality. Yes. What we have to do, we are actually working on calculating the water quality index by the Canadian, by the first method and the second method for the wastewater treatment plant of Tymoshenko, in order to summarize the number of the parameter. Maybe we will have just 1 or 2 indices instead of 10 or 9 parameters, and it will give a better view related to the water quality. For the second case study is the wastewater treatment plant of Tlemcen. For this wastewater treatment plant, we had more than 2,000 samples were collected between 3 years, daily samples, with also 10 parameters, and the objective was to access the water parameters and to analyze and evaluate the water quality indices. Yes, this is the first table summarizing that the range of the quality is good or quite good in general for the wastewater treatment plant of Tlemcen. Yes, we are still working in order to develop to calculate the water quality indices using the arithmetic method, in order to compare which method will be suitable for this kind of wastewater treatment plant. Yes. The 2 first examples were related to the quality. In terms of quantity, related to the 3 last decade, we had preparing like scenarios, strategy decision making of sustainable water management using the WIP model, and we worked with data of 30 years. We can see that the different options used here are just for the urban demand. We use the data related to the groundwater, the desalination, and surface water. Yes, we can see after the last 10 years that the volume of desalination are very important. Yes, the general methodology is to define the study area for us. We worked on Tlemcen. We are still working on Tymoshenko, using the WIP model, and then calibrate and validate, and then define the different scenarios in order to have or to analyze the different results. Yes, our first result, the water supply and demand of the study area were accessed over the past 3 decades. The water evaluation and planning WIP model or system was employed considering different future scenarios to help decision maker in considering the best choice of sustainable urban water resources management. Our first result showed that the average water production and distribution efficiency was only 46% due to the high network losses. A part is related to the leakage. Therefore, an urgent action should be considered to increase the efficiency of the distribution network. Moreover, the outcome showed that a severe unmet demand in the coming years, which can be managed by improving the water networks and reducing personal water consumption. We are still working on the climate change scenario and agriculture scenario. Yes, in cooperation with the key stakeholders, for us, there are 3: the National Agency of Water Integrated Resource Management, the National Office of Sanitation, and the National Office of Irrigation and Drainage. We will work on new scenarios. We will analyze them to develop an efficient water management policies and to implement a sustainable water allocation approach. Yes. Thank you for your attention.
Thank you. Thank you very much. We have a discussion from Abdel. Oh, sorry, I forgot I didn't use. Okay, let's open for questions, Q&As, because, okay, no, that's fine.
But my paper is still not completed.
Still ongoing?
Yes.
If there are some questions, we have a little bit of time. Yes.
Chérifa, thanks for the very nice, interesting presentation. I was wondering, in the application of the WAPE model, what's the geographic scope of the modeled area? Yeah,
Yes.
yeah.
Do you mean slopes and the?
I mean the area.
Yes. Yes, for the input.
No, usually when you run studies,
Yes.
your studies are based on some geographical locations.
Yes.
He's asking where your geographical locations were based.
In the western part of Algeria. Yes, I said that all the application, all the case studies were chosen in the west part of Algeria because this is a part like with a serious problem of scarcity. Yes, and we had a problem on allocation of the water resources. Okay, the reason that, for example, for Tlemcen, the town or the city is fed by desalination plant. It is the case for Ain Timoshent. Yes.
So you covered multiple river basin in the western part of Algeria.
There is mountain and there.
I mean, more than one river basin. There are several river basins.
I didn't get the idea.
Oh, okay. So WAPE is a river basin based
Yes.
optimization-driven simulation model. So you apply it to more than one river basin.
Okay. Yes. Yes. Yeah. I got the idea. Yes.
Yeah.
We applied it to the river basin of the Orani Sharqi. It is like the whole river. It is called the hydrographic.
Yeah.
Yes, basin. It contains Timoshent and then Tlemcen.
Oh, okay. Thank you.
Yes. Welcome.
Any additional questions? All right, now that's fine. Now the energy is going down. You don't have to feel bad if you don't receive a lot of questions, right? But this has been an interesting presentation.
But for me, it is, I don't know. I'll ask you if you have any idea that can help us in order to develop, especially the socio-economic part.
Right.
Yes.
Right. Now, this is a great question, perhaps which we can take outside of the room.
Thank you.
For the sake of time constraint, but definitely we can do that. Right. The next presentation is from Sarah.
So good. So you're still doing timekeeping? Good. Yeah, I'll need it. All right. Hi, everyone. Hope everyone's not as tired as I am. But yeah, so my talk today, there is no equations. This is a high-level policy paper. I think I show a scatter plot. That's as complicated as this talk is going to get. So I want to acknowledge my co-authors, Professor Seelan Nurges and Professor Quinton Grafton. So we've all been working together for a long time, and we were working on some work that we did for the Global Economics Commission of Water on water markets and water prices. And when I was invited to come to this forum, and thank you very much, I have very much enjoyed myself, and to present a paper, on issues in the Global South, it made us think, okay, how can we write this paper, and, what in terms of principles and practices and proposals like recommendations, what would we recommend for the Global South versus the Global North? So that's what we've tried to do in this paper. It is very much a bit of an experiment, and it's very much an outcome of, for all of us, of decades of working in this sector. So trying to bring some lessons about what we've learned over time and put it in one paper. Whether we succeed or not, I'm not sure, but it's something that we're working on. Okay, and I'm just going to go through this very quickly because this is all background stuff and you all know it. We're in a severe time of change, flooding, droughts, heat waves, etc., all changing outcomes and social welfare. In terms of ecosystem change, we haven't talked that much about it here, but it is a serious thing. And these graphs I pulled from the World Wildlife Fund, their latest report, I really actually liked it. Some of their valuation methodology is a bit questionable, but I think the message and the overall graphics and the way it explains things is really quite nice. We're not on track in terms of meeting SDG goals. And one thing that you guys all know, but that I often emphasize, is that, water is not just one goal. It goes across all of the goals. We're talking about health, nutrition, food, gender issues, fisheries, land, etc. So, when we're dealing with water issues, we're dealing with a lot of issues that affect society. And that's something that's really important. In terms of, addressing how we deal with water security and water pollution problems, supply side management and large scale centralized grey infrastructure, it's been critical in how we're dealing with it. But there's also significant social, economic and environmental costs that are associated with some of this infrastructure. And that's something that we need to take into account. So in terms of water policy tools, what I always try and get through as a water economist is that we have supply management and we have demand management. We have a variety of tools at our disposal when we're dealing with water security and water quality problems. All right, there is no silver bullet. There has never been any silver bullet. I talk about the 6 Ps. This is one projects being supply side. So supply side, you have both traditional grey infrastructure. This is dams, storage, desalination, recycling, piped wells, irrigation infrastructure, etc. And then you have the green infrastructure, which we've talked a little about in this forum, using wetlands, using managed aquifer recharge, using watersheds, riparian buffers, etc. So that's on the supply side, the green infrastructure. That's what's known as projects. And then we come to our demand management-based tools. So these are things such as education, preaching to people, voluntary behaviour. We regulate, we police, we price. There's property rights. Property rights involves water markets, which is what I'm going to talk about. But it also includes things such as giving legal rights to rivers, common property rights, etc. And the final thing that we have to do, because there is no silver bullet, is planning. Planning is where and when do we implement all these different things? At what scale are we going to put supply side, a new dam in? At what side do we put demand regulations in? And these things can vary too over time. Okay, so this talk is going to focus on the economic incentives, namely pricing and water markets, because they often, unless the economists are in the room, they tend to be ignored quite a lot. So we're going to talk about some of the issues associated with pricing and markets. Okay, this graph is about water costs. All right, we've heard a lot about water costs, but I thought it was worthwhile putting up this diagram. Comes from a World Bank publication. So when we talk about water costs, this especially is true in terms of urban utilities. You have your capital expenditure costs. So, the costs of putting in dams, networks, pipes, you know, your fixed costs that can be really quite lumpy and expensive. Then you have your operating expenses. So, you know, once you've actually got infrastructure in place, we have to actually have management, we have to have imports, we have to have specific costs, the operating expenses of actually operating that capital expenditure. All right. Then you also have costs of infrastructure include environmental costs, resource costs, and externalities. And Slim gave us some very good examples of desalination, some of the environmental costs of brine, for example. So, you know, that's what some of the environmental costs are. And you also have inefficiencies that are associated with water costs in general. So that in terms of pricing, when you're pricing, we have to worry about, you know, what are we covering in terms of these water costs? So there are lots of different water pricing options that can be employed and that are employed right around the world. You have fixed charges, which is a connection charge. You can have a two-part tariff, which was your fixed charge plus a single or flat volumetric price. You can have a fixed charge plus a non-uniform volumetric price. So this is often known as an increasing block tariff. This figure is illustrating a block tariff. It's incredibly popular and it's applied in a lot of countries around the world, especially in the global south. And the idea is that, you know, as you use more and more water, you're meant to be paying higher prices. You go to a different block and you're paying higher prices. Another form of a pricing option is a volume differentiation tariff or a jump tariff, where all water use is charged at the price of the highest block. Okay, so that's some pricing options. So some of the problems when agencies are using water prices, they're trying to meet more than one objective. All right, this increasing block tariffs are trying to meet more than one objective in terms of also trying to address poverty, cost recovery, affordability, and efficiency. All right, so it can be a problem from an economic perspective when you're using one instrument to try and cover lots of things. It involves trade-offs and often it can fail. All right, so some of the challenges that we see in the world is, you know, price of water, and we've talked about this a lot, is often too low, and all those costs that I was talking about are often not covered. So in the global south, in work that's been done by the World Bank, you know, only 33% in the database are actually covering their operation and maintenance costs, let alone all the other costs associated. In the whole database, only 13% of utilities were covering all their costs. So if you're not covering all their costs, you know, they're not going to be able to maintain infrastructure. They're not going to be able to expand infrastructure. They're not going to be, quality is going to decrease. These are all the problems that often occur. Increasing block tariffs, they often fail in meeting equity objectives. And you have issues with collection because people don't understand it. And then agencies actually can't collect the money from the increasing block tariff anyway. One of the reasons is this complexity and not understanding it is why we think the water demand is often found to be price inelastic. And Maria gave us some examples of lack of information there. So that's some issues in pricing challenges. This is the scatter plot. So what we did was just to look at the relationship between water prices found across all different countries. And so World Bank often classifies as the red, the low income, as the global south. The blue is generally the global north, as well as the purple, and the green is kind of in the middle. So this is trying to look at, is there a relationship between water stress and water prices? Do we see anything? And pretty much you don't see anything. The only thing you kind of get out of this graph is, yeah, in general, you know, global north is charging higher water prices than the global south. But there is a lot in between. And the US is an example of actually charging quite low water prices in some areas. So, you know, there is a mixture between global south and global north. So now we come to the second main economic incentive we can use in sharing water, is namely water markets. So there's two main forms of water markets, informal and formal. Informal trading is often involved where you might have, it might be legal informal trading in terms of you are getting it from a monitored and regulated water source and then sharing it out to people who don't have piped infrastructure, but it can also be illegal. So from boreholes that aren't regulated, tapping into a pipe supply and stealing water. There's a wide range of informal water market. A formal water market is a formal trading. It's a recorded trade of water between buyers, voluntary buyers, and voluntary sellers, and it exists in a form in a set of institutional rules. There's lots of rules about how the water can be traded, where it can be traded, how it can be traded. The graph here, I've just given an example of the Murray-Darling Basin where I've done most of my work. It highlights that water prices are allowed to be flexible. In the water market, it can be completely flexible, and it really depends and is driven by scarcity and available water supply. So there are a number of water markets around the world, both, I mean, you find informal water markets pretty much everywhere, but at different scales. But you don't find that many formal water markets. But there might be more here than people actually expect. You've got formal water markets in China, US, a little bit in Canada, Australia, some in Chile we've heard about. So there is a number of water markets around the world. I'm not going to talk very much about types of water markets, but, you know, you have temporary. That temporary is like renting a house, and permanent is like selling a house. So you can have temporary and permanent transfers, and you can get a range of benefits. So economists will talk about the allocative, the dynamic, the productive benefits that you get from water markets. The thing that I emphasize the most is that water markets allows for adaptive decisions and flexible behavior. So that is one of its most important, you know, allows you to adapt to water resources that are becoming more scarce. On the other hand, you know, there are negative impacts you can have from formal water markets, and it's something that you always have to assess. Because water markets only exist in a set of institutional rules, if you have market failure and you don't have strong enough regulation, this is where you can have problems. So there is to set up a formal water market, you need a lot of conditions in terms of scientific hydrology information. You need to have net benefits from trade, and you need strong monitoring and regulation. Because of all the conditions you need for a really successful operating water market, this is one reason why there aren't, if you're looking at the global south, there aren't often enough conditions for a very formal water market to exist. We'll come to insights. Now, I don't expect you to actually see this at all, but this is highlighting, this is from a book I did on water markets around the world. And the only thing I want you to kind of recognize in these graphs is, you know, we're comparing global south countries with global north countries. On the left here is all the different conditions you need for a successful water market, and then comparing by country how much it actually met institutional conditions. With the exception of China, if we're thinking about a formal water market and development in like 3 steps, China is the only one that reached step 2 in terms of conditions needed for a formal water market to be successful. And in the global north, you have much more meeting various conditions for water markets to work. But having said that, there's only a couple of countries that actually meet all the conditions for step 3 for a really successful water market that's operating well. So that's just a bit of a comparison. So now I get to my 6 best practice lessons. How am I going for time? All right, great. Okay, so this, I'll just tell you the 6, then we can talk about them. So we've talked about The recommendations for water pricing include environment, resource costs and water prices, use one water policy instrument. Recommendation for water markets, facilitate water trade. Don't necessarily facilitate water markets, facilitate water trade, water transfers. Initial property rights matter and overall water governance recommendations, because you can't talk about pricing and property markets without talking about governance. We're highlighting that regulation, monitoring, enforcement is critical, and funding water utilities and regulatory agencies is very important, as well as developing proper water accounting. So we come into more detail about the pricing recommendations and what differs between Global North and Global South. So in terms of including environmental and resource costs, including true values and opportunity costs of water is very, very important. Global North countries, we think, should be looking much more at developing water scarcity and pricing to reflect that, both within capital expenditure and maintenance and management. We don't feel that they're probably doing enough in that space. And Global South, we think, should be focusing first on pricing for capital expenditure and maintenance and management. Otherwise, if you're not pricing properly, you're going to get into a vicious circle where the infrastructure is going to degrade. People will be less happy to even think about paying higher prices, and you're not going to be in a good place. In terms of what type of pricing we're recommending, we're saying use one water policy instrument. So for the Global South, we're not recommending the uses of IBTs. We think much more simpler tariff schemes are best, probably a fixed connection, wherever possible, base that fixed connection on the value of the property. So this is where you get some of the difference between the wealthier and the less wealthier. And then just one single volumetric price that reflecting marginal costs, with those marginal costs including the environmental and resource costs for everyone. So when it comes to poor households, we much prefer recommending cash transfer payments or rebates. So we think advocating for a much more simpler pricing system is going to basically, it allows utilities to be able to educate and inform a lot easier, and hence increasing their collection rates, and hopefully drives more trust. And with more trust, if prices are increasing, you can get politicians on board, and you can hopefully get to a viable state where the utility has enough money to not only invest in the current infrastructure, but invest in our future infrastructure. For the Global North countries, obviously we feel that subsidies, Global North should be not subsidising at all, and this is certainly a problem in agriculture for water use. And, again, focusing on water scarcity pricing. For water markets recommendation, so because of the meta governance needs of water markets, we are not advocating water markets for every country in the world. But what we think is very important is the distinction between a big, large formal water market and facilitating water trade or water transfers. All right, so there is capacity for increased informal water trade in countries all around the world. So the more you can encourage users to share water, the more you're going to enhance adaptation. So that's one of our key recommendations. For Global South, and when you think about institutions, you've got to, enforcing and establishing caps and sustainable diversion limits is key. Global North countries do it a bit better than Global South, but they also have to focus on that. And they have to focus on enabling legislation and monitoring water use and regulation. We also think there is much more possibility of using satellite technology, and that Global North countries, an international database of monitoring water use and how by satellite is a sort of institution that should be thought of, because capabilities in Global South to do that are not as strong, and it needs a lot of investment and high skills. Initial property rights distribution matters. So in terms of water market recommendations, it's important to note that who owns the water rights is critical, and colonisation factors really matter. And so for water markets and who benefits, this is something about who owns property rights and how do we redistribute is very important. And I'll quickly touch on water governance recommendations. I've said it before, I'll say it again, regulation, monitoring, enforcement is very important. This is where a satellite measurement, for example, of water use is critical. Global North countries, you know, they can develop a lot more of their legislation, their compliance, their social norms, and Global South needs to really work on capping sustainable diversion limits. Number two, fund water utility and regulatory agencies adequately. You know, water bodies need a lot of money for baseline funding, for reinvestment, accounting, and compliance. It's way easier for Global North to do this than the Global South. We do recommend separating regulatory, the function of regulation from, for example, general water or agricultural objectives. Often they can be tied in the one department and you can have problems. So separating agencies is key. So finally, that's it. You know, what we want to be, we want to be on a virtuous governance adaptation circle. We don't want to be in a vicious circle. So that's it. Thank you.
Thank you. Thank you very much, Sarah. Let's invite Linus to provide the discussion.
Okay. Thank you. So when I read through the paper, the first impression I got was definitely that the idea of the paper is relatively straightforward. I also like the use of descriptive analytics because I thought it was appropriate. It is written more as a guide for practitioners and policymakers in developing countries, and something you did point out. And I think this by itself is a good contribution. The comments that I will share with you, and I should point out that you have written extensively on this subject, right? I enjoyed reading the literature that you shared in the paper, as well as your analysis of the literature. So my written comments that I will share with you are going to focus on the structural aspects of the paper. And if you agree with them or some of them, this may also have implications for some analytical aspects of the paper itself. I thought that sections 2 and 3 of the paper could be better integrated. I would even say sections 2, 3, and 4 in some way. In particular, I thought as a reader, I would be better off with section 4, which is where you present key proposals in the appendix, and then provide a little more elaboration on those key proposals or recommendations in sections 2 and 3. And the reason I like that approach is because you are writing this for a policy-oriented audience. And I think it would be better to provide them with a little more analysis in sections 2 and 3 to be a little more specific. You correctly point out the challenges of water markets in section 3. For example, you talk about the issue of the assignment of property rights. You talk about externalities. You even talk about the issues related to market structure. But it appeared to me that these issues do not get enough attention in section 2, which is on water pricing. It made me wonder if it is better to sort of switch positions, the positions of sections 2 and 3. That is, you cover water markets and associated issues, and then incorporate the implications of these issues for water pricing. I definitely understand maybe why you took this approach. I usually have a debate with my colleagues on whether do you recommend students take principles of microeconomics first, or they take principles of macroeconomics first, right? Some of them say it doesn't matter. Some say take principles of macro first, but this is a case where I sort of agree with them. It may be useful for you to discuss the issues around market structures, externalities, property rights, so that when you start discussing pricing, you could discuss the implications of these issues for pricing. That's my thinking here. And I have other, I would say, minor comments that I will share with you in written form.
Thanks, Linus. Sarah, if you want to react to these comments?
Oh, no, I think that was, yeah, I think that's quite insightful. I'll discuss with Celine and Quentin. I mean, our biggest problem is space. Yeah, so yes. So you're thinking section 4, which was recommendations, put in an appendix, free up a couple of pages for more detailed. Yeah, I think that's quite, yeah.
Yeah, I mean, I'm thinking more about the audience, right? You're writing this more for audience in the developing countries, policy makers in particular. And I think providing a little, call it little more meat.
Yeah. No,
right,
no, I hear you.
Them. Yeah.
That was always my problem. I mean, I thought potentially it's too much as well.
Right.
2 papers in one.
Yes.
But that's also the point of it, because anyway, no, it's all good.
Open up. 1, 2, 3, 4.
Very good presentation for so late in the afternoon, so thank you. I'm curious, a lot of the research is done at the country level, but we know that obviously if you get more granular, I mean, you can look at California, for example, and there's some places that might be more ripe for a water market than others. And I'm curious if you can just talk about more local nuance, especially maybe in the global South compared to the global North, how that local nuance might come into play in terms of how you think of where water markets might fit.
Yes. Yeah, no, but very good point, Christina. So part of the issue, so when we do analysis on water markets, it's on formal water markets, it's the area through which water can be transferred. You know, is it hydrologically connected? So if you're talking about, and I didn't really touch on this, but we're talking about a surface right market versus a groundwater market. You know, they have different catchment areas. You know, if I take Australia as an example, we can trade water from New South Wales right down to South Australia because it's hydrologically connected. All right. So that, even though we're all one country, that's going across 3 different state boundaries, and states are what control water resources. So when you're talking about allowing a regulated trade in you have to worry about, is it hydrologically connected? But this is where you need strong governance and institutions the fact that that water is coming from that area there and going to, you know, an area thousands of kilometers away, that it's regulated and that, you know, water use is controlled and monitored and changed, right? So when you're talking about conditions needed for a water market, you have to understand the hydrological conditions, but we also have to understand the institutions from where the water is coming and whether we can actually regulate, you know, A, how the water is extracted and used, and B, you know, whether you're stopping water use from wherever the water has been traded from. So in a global South perspective, this is where even if you have a large area that's hydrologically connected, but you're not regulating and monitoring it well, this is where allowing water trade, when I say, you know, the difference between a water market allowing lots of trades to occur across lots of different people in space versus a water trade tends to be a lot closer. And so it's easier to know within a certain area, you're just allowing some informal water trades versus big water, a longer distance is to actually occur. Now, I'm not sure if I explained that hugely well, but yeah, the issue is, you know, the bigger the market you make, the longer the area, you've got to have much more stronger institutions to monitor that versus allowing water trade in a certain area. You can control that a lot better without it being fully formalized.
All right, we have 1, 2.
Yeah, thank you very much for a very good presentation and keeping us awake even at this late hour. I think I have really a question about full cost pricing, because ultimate objective is to move towards the full cost pricing, which has to remove the subsidy, depletion cost, and environmental cost. These are 3 things. I think the developing countries have not moved that far, but in developing countries, do you place a few countries which are really moving towards full cost pricing?
Well, a lot of countries do it. Yes, they do. And they're also planning for not only just full cost pricing, but for, additional investment. So whether it's going to be in a desalination plant, whether it's expanding, piped infrastructure area, a lot of countries do it. But, I gave that figure out of the IBNet database. Only 13% of the utilities in there were covering all their economic costs. And when they say economic costs, that didn't include accounting for future water scarcity. The issue with that IBNet database is it has more utilities from the global south than the global north. So we can't say, well, that's a true representation of utilities across the world. But I think the highlight is, global north is more likely to do it than the global south. But still, you still get many utilities in the global north that aren't doing full cost pricing, and they should be.
Thank you. We have one question here.
Thank you for your presentation. For me, it was very interesting because with your presentation, I could see very clear, that the comparative studies are very useful in terms to understand the differences in between regions as North and South global, and also with the focus in water markets. And I think that is very good to have, the perspective more open, and to understand the links and the differences also. And for me, it was very good. And also, something interesting was to do typologies, in terms of the different kind of markets, also different kind of actors in the markets. And it's very good. It's very useful with a concept, water market. You can do a very more deeper analysis, And thank you. And also, yes, the last one is to include more things in the water markets. For example, the social issues, the environmental issues that sometimes the economical models are a little bit limited, and we must innovate in that one.
Yeah, no, thank you. Just I'll make a general point. I tend to, I tend to be a proponent of economic incentives, but I recognize the problems with it. But I'm often the only water economist in the room, and so I'm the only one ever generally bringing up water pricing and water markets. So I tend to often end up arguing for them a lot, but part of it is because people often tend to reject them outright. And so when people, utilities, etc., are rejecting management options outright, you would tend to try to actually say, well, these are all the benefits. But thank you.
All right, thank you. I think our time is up. We can just move to the next presentation. Abdel.
Hello, everyone. So my presentation is about it's a discussion paper about the use of an investment feedback strategy to deal with water scarcity. So the idea is to look at this, is to test this analytically, to test this kind of strategy and look at the results that will be show us. But all the analysis remain theoretical and there is no numerical application of this because of lack of data, of course. So my presentation, I will be presenting after a brief introduction, explaining, giving a quick overview of the background of this, of the analytical model I use, and then I will be presenting the analytical framework, and then discussing the economic efficiency and some policy implications before concluding. So when we look at the world map, then we are discussing here, we are discussing water scarcity, and we have seen that water scarcity is a problem that almost all economies deal with. So when we look closely to semi-arid and arid areas, what we see is that in these regions, for example, the projections for the future evolution of the scarcity, scarcity is tending to be more and more intensified in these regions. And in this map, we see, which is the projection for 2040 horizon, in change in water stress, we see that almost there is a superposition between these semi-arid and arid areas and the projections of water stress in intensification in the future. And this intensification causes main economic and social problems. With increasing scarcity and decreasing water stress, we have an increase of competition within the economy about the use of water, mainly in sectors that are highly dependent on water use, like agriculture, industry, energy sectors. And this intensification of competition widens the scarcity gap within these economies. And widening this scarcity gap will produce a negative feedback on the growth within these economies. So growth, the economic growth, will be affected negatively by slowing down the economic production in the long term because of this increase of competition around water use. So there is some projections that are published by the World Resources Institute, which are data from the Global Commission of Adaptation and the World Bank, which shows that if we continue with business as usual, we have a decrease, like in the MENA region, which is around minus 10% of the GDP because of water scarcity. And if we implement efficient water policies, then this minus 10% can become minus 6%. And in some regions, there will be an increase of 2%, going from minus 66% to plus 6%. So there is an impact, seems there is an impact on the GDP. And this needs to address the situation. We need investments, and the investment can go up to 20%. And we look at the most African countries, the cost of addressing water scarcity or investing in water sector are very high. So the challenges we are facing is that there is this climate change and demographic changes which are going very fast, and this is the main problem. Because the problem now, because societies in Africa or elsewhere, they have always learned to adapt to climate changes. But now the problem is that the speed of these changes. And now if there is this speed, so the idea is to test if public policies can change or introduce more flexibility in the way they are dealing with water investments, so to increase this speed or to adapt it to what is observed as realities. So, but investing in water scarcities faces many problems. We are talking about semi-arid and arid areas. In these economies, we have low economic growth. So we have low level of resources at disposal to invest, and budget availability is very limited of this limited growth. And we have also competing development investment in these countries. The needs are very wide, and there is not only a need to invest in water scarcity, adding to all that the high cost of the water infrastructure. So the objective of the study is to understand, like I said before, to understand how the dynamics of scarcity can be controlled by adaptive public investment strategies under the effect of prevailing contextual conditions. And this adaptive feedback is aiming to close the water scarcity that we define here as a balance between water quantities that are used for both extractive and non-extractive uses. And we conduct this theoretical analysis and the analysis also of the efficiency conditions. The assumptions we start with is that there is a state of water supply in every economy that is governed by or influenced by external or exogenous factors, mainly water demand and environmental conditions that are prevailing within this context. This state of water supply defines in interaction with demand, defines the scarcity level. And according to the scarcity level, if we set a public investment strategy that is based on scarcity level observation, then there will be this public the definition of investment according to this. And we introduce, in addition to this factor, we introduce the possibility of social pressures or social claims, because mainly when there is water scarcity, people start or societies start to claim or they ask the governments to make efforts in terms of investment to ameliorate the situation. And there is an indirect effect through the aggregate output, like I said, because low growth rates in these countries can be a hindrance for public investments for the mobilization of enough capital to respond to water scarcity increase. And we consider a cost function that is a discount net present value of the overall net cost society bears due to water stocks depletion or to water availability decrease. So we consider a function of cost that is dependent on the scarcity. So scarcity defined, we will see the equation that defines the dynamics of this scarcity level. And we consider here, what is interesting is that we consider the capital, this function, which is the investment function that depends only on the observed level of scarcity. And all these costs discounted to the present time define the cost for society, or what I call here the social cost of water scarcity, which is both monetary, includes both monetary and non-monetary dimensions. And here, for the scarcity dynamics, it's the evolvement of the relation between demand that we consider an exogenous factor, and the function that is that describes the green infrastructure we have and the water yield by this green infrastructure. And we consider that this green infrastructure can be ameliorated. Their capacity can be ameliorated through an investment share, which is beta, an investment share from the whole the total investment, which is alpha plus beta. And we consider here that this function E is a function of investment in gray infrastructure, and both the interaction of both with demand, like I say, demand here includes the quantities of water, but the quantities that are used for both social uses or as for the external positive, the external benefits of water, and also the extractive use. So it means that when there is no investment effort, there is only the interplay between demand and the natural processes that are undergoing within the economy. And we consider that this water demand interacting defines what is the evolution of this water stock that is described here. And then this defines the water scarcity, which is observed by society, like in form of social cost. And then this, depending on the social cost and depending on the reaction of society, which is the claims to invest more in water, and the observation of the stock level of water under the exogenous factors. So we have this investment decisions. So we'll be looking to this investment, I try to specify like this social cost function, which includes the initial state of the cost level of the cost and other costs, namely the cost of operations and the cost of related to the depreciation of this capital or the fixed investment in infrastructure, and also I include here the inefficiency of institutions in terms of implementation of investment in water infrastructure, which is described by this parameter that depends on time. And the second part is the aggregate cost function describing the effect of water scarcity on the economic growth. And last one is the health deterioration or the impact, the general impact on the human capital that water stress can cause. So we end up with this result, which describes the growth of the unit social cost of water scarcity, which depends on the social rate of discount and the net, what I call here, net effect of capital per unit of unit cost of scarcity plus the velocity of scarcity. So the speed at which scarcity evolves within society, and this net effect of capital is described by this equation, which involves operational inefficiencies, monetary expenses, the effect of investment on growth, incremental investment, and the effect of investment on social monetary costs. So to go fast, just in terms, if we do according to that equation, if we do nothing, so if we imagine a policy that where there is no investment, we have the social cost that grows up according to the social rate of return, which means that the interplay between demand and the natural processes that govern water normally should make grow the cost at this rate, which is the social rate of return. In case we have policy, so this point in terms of opportunity cost regarding in relation with what I said previously, the trade-off these economies have regarding whether they invest in water sector or they use money to make it more beneficial in other development priorities. So at this point, we have like a kind of equilibrium where with the society theoretically will be indifferent between investing in water or not. So it means that there is a kind of equilibrium here, but at this point, normally the investment is not profitable from the social point of view. It will be profitable since when the cost rate of change is greater than the social rate of return. So it means that we will be it's possible to be in three kinds of situations. The first situation is a context when we invest in a context with growing scarcity. Then we have the velocity of scarcity, which is positive. Then we have the most profitable part of this, the most profitable strategy for investment with stable scarcity. So it means that when we have policies that aim to stable the level of scarcity, then we will have an effectiveness which is in positive terms. So it means that the cost will be higher than zero. So there will be a cost to maintain the stability of scarcity level. So scarcity change will be zero. It means like we have a constant stock of water that responds at every point in time to the demand. If we want to go beyond this objective or beyond like a norm, social norm, like what we find in international indexes like Falkenmark Index, for example, if we want to fix this kind of objectives beyond the quantitative objective of stability of the scarcity, then we will see scarcity increase decrease, and this kind of strategy, it's like it corresponds to situations where we go beyond satisfying the needs expressed by demand. So it means that we are forming a positive stock of water beyond the need of the economy or beyond demand satisfaction. So what we see here is that it's like if we continue the effort of investment, we have three kind of policies, three main policies, and one with stable level of scarcity where the investment will not be profitable, and the investment in other sector will be more beneficial. In context of accentuating rapid scarcity, this is the highly beneficial policy, and scarcity stabilization will come at a cost, at a positive cost, and it is not the most efficient. It will be less efficient, and increasing water availability, it will come with more costs or additional costs, which means that with limited budgets, public budgets, we will be at maximum we can do is arrive to this point, and going beyond will be very difficult regarding the opportunity cost that we will have. So what we see is that the rate at which scarcity develops is crucial to determining the ultimate impact of investment that have been made or to make. So when we see this, we should go back to the details of this scarcity speed, which is determined by the green infrastructure, which is here. This equation shows us that this velocity of scarcity is contingent on the effect of capital on both the gray infrastructure and the green infrastructure. So here we have, in reality, what we have is that policymakers they prefer gray infrastructure because they are of low uncertainty level, and the investment in green infrastructure are judged to be less efficient. If we want to go beyond, then if we assume these relationships which include the innate ecosystem capacity, the effectiveness of the chosen green infrastructure to be implemented, and the shares of capital for each infrastructure, gray and green infrastructure, then we assume these linear relationships, we will have an equivalence between the shares we have in gray infrastructure and green infrastructure. What we see here is that the gray infrastructure will have a bigger share in terms of capital. If we have this because we have this relationship, we have this term which is greater to 1, which means that when we choose the green infrastructure implementation, we will be choosing at least an infrastructure that is equivalent to the green infrastructure that already exists. So this gives us this result, and to be at equal efficiency, then we should define shares of capital between these two infrastructures this way. So it means that in terms of efficiency, we have an efficiency that is decreasing from this situation, from situations where scarcity is escalating, so the speed of evolution is very high, ending up with very low efficiency level when we look to yield more water than needed within the economy. In terms of action strategies, so in terms of control, going back to the idea of the social pressure. So for the social pressure, if we want to lower the social pressure, we can control for the cost growth, or we can control for the velocity of scarcity if we want to have a physical balance within the economy. This strategy has some underpinnings which are as follows. Like in the short term, as the scarcity lowers, the investment becomes less profitable. And there is also this problem of lagged benefits of investment in this kind of infrastructure, because benefits to show up, they need time, and to conciliate the short term and the long term. It's about the choice of the social rate of return to use to compute the cost. So for controlling units, we have non-efficient policy to control. So it will be non-efficient to control the rate of increase to zero, and it will be efficient starting from this level, from the level of this ratio of unit cost increase, and high efficiency if we get to define like a kind of resilience or tolerance vis-a-vis the scarcity. So the investment will be highly efficient in this case. The question here is when to start. So when we want to implement a feedback policy, when we should we start? First, starting with measuring the physical scarcity, because we show that there is a relation between incremental capital investment and this scarcity, measuring the divergence between quantitative control objectives, and defining the maximum need of capital according to the equation 5 I showed before. So feedback control doesn't mean that we should follow the fluctuation of precipitation levels. It's just a technique to see how efficient would investment in the water sector would be regarding the opportunity costs we can have when we leave investment in other development sectors. So it means that the pace or the intervals of investment or the time of investment will be chosen according to subjective reasons based on the decision maker criteria. And it doesn't mean that the investment where geographical locations, investment where the geographical location is secondary. So it means that when we choose locations to implement this kind of investment, we should choose locations where there is the most increase, the most high speed of increase of scarcity. And the investment in water supply is not sufficient. We have seen that scarcity is influenced by both scarcity and both demand and so there is other aspect. I will not have time to present all this. What I want to say here in terms of conclusion is that now water policies become more and more local, and we are insisting on sustainability issues. This technique could be used to prioritize locally while respecting the trade-offs of development we have nationally, and there is also the necessity to act both on supply part and demand part, and with supply part mixing these two kind of investment, which are green investment and gray investment. I'm sorry I couldn't finish, so thank you for listening.
All right, thank you very much. We have the discussion from Sarah.
Okay. Thank you. I enjoyed your paper. What I really liked about it was that you looked at green and grey infrastructure in terms of addressing water security and sustainability issues, because lots of people often miss out on the green infrastructure. I'll make a couple of comments. So one thing in terms of, when it comes to supply management, grey infrastructure investment, there's been a lot of work that shows really the costs of investing in supply infrastructure is pretty much always underestimated. There's a report that shows that 96% of all grey infrastructure projects will run over cost. So generally, we underestimate the costs and we overestimate the benefits of supply infrastructure, supply grey infrastructure. So I think that's something you could take into account a bit more. And at the same time, the benefits of green infrastructure are actually underestimated a lot, which you mentioned, while engineers and decision makers often overestimate their costs because of the uncertainty. So that's just some general points about when we're talking about supply infrastructure. You had no demand management policies in there. I don't know how easy it is to add some demand management to see how that actually changes as well. I know it just adds another layer of complexity. Yeah, I get that. So that could be a potential variant, or it could be a new paper. But one thing I would really like to see in your changing assumptions, so one of your main assumptions is that water use is by individuals is independent of water stock. So in terms of, you create a new water supply, you're basically assuming that it doesn't change water demand. The reality is that we know across the world that's not true. You create a new water supply situation, you basically lead to increasing water demand. There's a feedback loop. We see it in urban consumers, we see it in farmers. So that feedback loop does exist. It's also known as Say's law. So supply creates its own demand, and that's been shown. So I think I think you can vary that assumption and see how your results change. I think that would be quite valuable.
Thank you. Thank you very much, Sarah.
Just very quickly, thank you very much for these observations. The first one is exactly the reason I chose the feedback control, because because normally there is two strategies, optimization strategies, which are based on the forecasts, and this feedback control. The feedback control is based on the observed reality. So we wait until we observe and then we act. It is not based on the forecast. So we avoid this kind. The main advantage is avoiding overestimation of benefits or underestimation. If you look carefully at that, what we use to weight the decision or the decision turn point is the social rate of return. So there is no, I think it's what would be overestimation, maybe in the estimation of the costs, the social costs, for example, the impact on GDP, which is normally it needs to be estimated very carefully to avoid this kind of overestimations. For the feedback loop, you are right. We know that there is rebound effects and this psychological effect of increasing supply, which leads to behavior of increasing. When I say that demand is exogenous, it doesn't mean that it's constant. It is not constant, but it remains exogenous. We just don't consider the factors that influence demand. But it varies in time. It's time dependent, so it will be varying across time, over time.
Thank you.
Thank you.
Up.
Thank you very much. You just introduced to us a very nice theoretical suggestion how to deal with dynamics of investments over time with positive and negative results. I only have two suggestions. One, and I'm not sure because I don't remember if I saw in your paper that you shared with GB and he shared with us the reference list. And there is a paper that was published in 2018. And all your questions that you asked, all the questions that you introduced have been asked. I don't know if the approach is similar, but I think it will be useful for you to look at that paper. It is by Tsur and Zemel, T-S-U-R, and Zemel, Z-E-M-E-L, and it was published in Water Resources and Economics in 2018, issue 23. And the title is Water Policy Guidelines, a Comprehensive Approach. And again, asking when to invest, how much to invest, and in which subsector to invest. So very similar, at least to me, of what you have been doing. Second suggestion, and I don't remember if I saw an application, any empirical application in your paper, but I think that to make, especially if we are going to the Journal of Policy Perspectives, people would be interested also with some numbering, even if it is an example.
Yeah.
So these are the two suggestions.
Yeah.
Thank you for these suggestions. The paper, I don't know it. It's interesting to look at it. Okay, I will write. Okay. So for the second suggestion, you're right. I'm conscious of this, but to find this kind of data, like the estimation at the macro level, because the equilibrium is studied at the macro level, and then downscaled for prioritizing local projects. So I don't know if someone has data or interested to collaborate, to bring some data to collaborate on this. It will be very nice to implement it and to see what will be the results. It will be.
He did not in that paper, but in another paper.
Yeah.
And I tried to find data for California, and it was impossible.
Yeah. Yeah.
So even if make the data just to to give a sense,
an overview. Yeah.
Yep. We have a second question here. Oh, sorry. All right. Is there any other question? Okay, then I think we can bring this day to an end. Let me hand over to the chair for any closing remarks.
Thank you all for being here. Thank you, GB. Thank you, Ariel, and thank you, Still, for organizing this session. Yes, Christina. Well, I did say Christina, but yes, would you record that? Make sure she hears that I said that. I know it's been a long day, but it's been only a 3-day meeting as opposed to 5 or 6 or 7, so you can't complain. On behalf of the University of California, the Rosenberg Forum, again, thank you for your participation. I hope you established some networking and friendship, and you will hear from us once we get home and summarize certain things, and hope to see some of you in the next Rosenberg Forum in 2 years, which we don't know where it's going to be, but it's certainly still on planet Earth. We're not going to be on one of Elon Musk's missions to Mars. Okay, so I'll tell you that much. Enjoy your evening. Glenda, do you want to say anything adding to mine? No? All right. Thank you. Enjoy sunny afternoon. Okay, and GB, thank you again for hosting it.